This video is on the least common multiple of two or more numbers. First, I want to explain to you what common multiples are. If you take the numbers 8 and 12 and you list all the multiples of 8, you'd be listing the numbers 8 times 1, 8 times 2 is 16, 8 times 3 is 24, and so on and so forth. And the same thing for 12. 12, 24, 36, 48. This is kind of a dangerous way to find the least common multiple because you could add 12 to a number incorrectly, or you might not know your multiplication tables well. But it does show a good visual of what multiples are. I have the number 96 and 96 both circled because 96 is a multiple of 8 and 12. And I have 72 both circled. 72 is a multiple of 8 and 12. And so is 48 and 12. But, 24. But 24 is the least of the common multiples. So that's your LCM for 8 and 12. Now, there are three different ways of finding the LCM of two or more numbers. I personally like the upside down birthday cake method. It's also known as the ladder method. What you're going to do in this particular problem, we have the numbers 12, 18, and 24, and 2 goes into all those numbers because they're even. And they go in 3. 3 goes into 6, 9, and 12 evenly. 2, 3, and 4 times. Now I look at 2, 3, and 4, and there isn't a number that goes into all three of those, but I can break these down into pairs. 2 goes into 2 once and into 4 twice. And 3, you see that little arrow there? I'm just going to bring it down because because 2 doesn't go into 3. And then what I do is I make an L around these numbers, and this is your least, maybe a way of remembering it, your least common multiple. So 2 times 3 times 2, which is the numbers here on the right, and that's your greatest common factor, times the numbers on the bottom, 3 and 2, which are left over. And the least common multiple, those numbers, 72. Now I can use the factor tree and or the box together or separately. It's whatever your comfort level is. This is probably more familiar to you, but you're going to take the numbers 12, 18, and 24 and break it down to the prime factorization. So any number I put in this box has to be a prime number. 12 is 2 times 2 times 3. And there it is, 2 times 2 times 3. 18 is 2 times 3 times 3. 2 times 3 times 3. 24 is 2 times 3 times 2 times 2. And now, the M, over there the L stood for the little L you create. In this case, we want M, and I want you to think about most, the most number. So here, 8 is the most number of 2's of a factor. And 9, 3 times 3, is the most number of 3's. So 2 times 2 times 2, times 3 times 3, and you get the same 72. Here, I've gone into a little bit more detail so that you can actually stop it and read this if you wish. But basically, I did the same thing. I found a number, the greatest common factor of all of these numbers, until I ran out of numbers. So 2 goes into 8 and 12, and 2 goes into 4 and 6, and I'm left with 2 times 3. So I make an L out of my numbers, and 2 times 2 times 2 times 3 is 24. For 8 and 9, there is no common factor. 1 is the greatest common factor that goes into 8 and 9. So it's just simply going to be the product. Now, 8 and 9 are relatively prime, so the product, 8 times 9, is going to be your least common multiple, 72. For this one, 3 numbers, 48, 60, and 40. I picked this number because it actually shows quite a few places where we have to take 2 at a time. We'll get down to the second row. 2 goes into 24, 30, and 20, 12, 15, and 10 times, right here. 3 goes in 12 and 15, 4 and 5 times, but doesn't go into 10. So you see the arrow? I bring it down. Just bring down that arrow. And now I have 2, 5, and 10. Nothing goes into all 3, but 2 goes into 4 and 10, so I'm going to bring those down. And then I have a 2 and a 5 and a 5. Well, 5 goes into the 2 5s, but not into the 2, so I bring that down. And then you make your L again, and it's going to be all the numbers on the left, the greatest common factor, 2 times 2 times 3 times 2 times 5, and then times 2, which is left over on the bottom, and you get 240. What I'd like you to do now is to put this on pause and copy down these problems and try them, and then once you're done, put it back on and see how you did. Here are the solutions. 4 goes into 20 accordingly, and I circle, make my L. 4 times 5 times 8 is 160. 30 and 36, I get 6 and 5 and 6, which is 180. 1 is the only number that goes in. We can make an L, but we're not going to use the 1. We don't need it. It doesn't matter. It's 8 times 25, so it's the product of those two numbers, 200. Here we have 7, 1, and 3, or just 7 and 3, and get 21. That 1 is optional. Here, but we don't need it. 3 times 2 times 2 times 5, which is 60. And then 12 times 2. And you'll notice in both these cases, 2 goes into 2 and 4, but not into 3. And over here on this problem, we have 2 goes into 2 and 4, but not 5. All right, how did you do? All right, let's take a look at this one. This is probably more familiar to you, the factor tree. And again, you break these numbers down into their prime factorization. So 8 is 2 times 2 times 2, and 12 is 2 times 2 times 3. Circle the most number of 2's, as I have done, and the most number of 3's. So it's going to be 8 times 3, or 24. For this one, well, they have nothing in common. So I'm just going to circle my 2's and my 3's, and 8 times 9 is 72. This one's a little bit more involved. 48 is 2 times 2 times 2 times 2 times 3, and 60 is 2 times 2 times 3 times 5, and 40 is 2 times 2 times 2 times 5. I circle the most number of 2's. Okay, I've got a 3 here and a 3 here, but no 3 here. It doesn't matter. You just pick one of them. It's the most. 1 3 is the most, and 1 5 is the most. You multiply all these together, and you get 240. All right, I want you to practice this. Copy this down on a piece of paper and find the prime factorization of each of these, and use the box, or use the box separately, or use the tree separately, however you want to do it. And then when you're done, go to the next slide and you'll see the solutions. All right, so again, we're going to circle the most number of 2's and the most number of 5's. So that's 16 times 5, or 160. No, it isn't. It's 32. Sorry. There's 5 2's. 32 times 5 is 160. For this next one, the most number of 2's, the most number of 3's, and the most number of 5's. So 2 times 2 times 3 times 3 times 5 is 180. Here, we only have 2's in the 8, and we only have 5's in the 25. So 8 times 5 is 200. Here we have a 7 and a 3. So 7 is the most number of 7's, and 3 is the most number of 3's. Get 21. Most number of 2's here. Doesn't matter. Pick one of them. And pick, well, it's the only one. Pick the one and only 5. And you're going to get 60. Here, the most number of 2's times the most number of 3's is going to be 16 times 9, or 144. How did you do? This workforce product was funded by a grant awarded by the United States Department of Labor's Employment and Training Administration. The product was created by the grantee and does not necessarily reflect the official position of the U.S. Department of Labor. The Department of Labor makes no guarantees, warranties, or assurances of any kind, express or implied, with respect to such information, including any information on linked sites, and including but not limited to accuracy of the information or its completeness, timeliness, usefulness, adequacy, continued availability, or ownership.